ඒ ෆ්ලොයිඩ් එක මම හිතන්නේ කතා කරා දෙවෙනි කොටස තමයි ෆ්ලොයිඩ් වල තියෙන ඉතුරු වෙලා. මට බ්‍රයිට්නස් අඩුයි නේද? මේක කරානේ. ඒක ඩිස්කස් කරා. මේ ටික ඩිස්කස් කරා. නැත්නම් ටික තියෙන. මේ ටික තමයි තියෙන්නේ. හරි මට නම් පටන් ගන්න. තියෙන්නේ 23 අද 23 හරි 22 ඉන්න. හරි පුතේ අපි මෙතන නම් පටන් ගමු. බලන්න density of gasoline is 0.72 kilograms per liter at 10 degrees of Celsius. The coefficient of volume expansion of gasoline is 9.6 into 10 to the power minus 4 Celsius. What mass of gasoline is lost when buying 40 liters of gasoline from pump at 30 degrees of Celsius compared to buying the same volume from the same pump at 10 degrees of Celsius? The pump is not temperature controlled. So this is sort of a heat question rather than a fluid question. It's about the volume expansion of the fluids. So you just have to apply the expansivity formulas. So we'll come to this one in the heat. Second one is actually, of course, fluid mechanics, and it's continuity equation, I hope, because the tube is narrowing down, right? The inner diameter of the outlet tube of a household water tank is 5 centimeters, right? So inlet is 5 centimeters. It is reduced to 2.5 centimeters and then further reduced to 1.25 centimeters to speed up the water flow as shown in the figure. How many times does the water speed increase due to the total reduction of the inner diameter of the tube? Right. So they're asking how many times the speed increases. So it's basically the continuity equation. But you don't have to, go into 5 from 2.5, then 2.5 from 1.25 to get the final velocity. You can directly apply it from the 5 to 1.25 diameter. That would be easier, right? So let's do it that way, right? So the inner diameter of outlet tube of a household water tank is 5 centimeters, right? It's 5 centimeters. This is 5 centimeters and it's reduced to 2.5, and lastly 1.25 0.25 centimeters to speed up the water flow as shown in the figure. How many times does the water speed increase due to the total reduction of the inner diameter of the tube? So it's A1 V1 equals A2 V2 basically, right? It's A1 V1 equals A2 V2, right? So it's the diameter. You have to take the radius, right? Inner diameter is so phi r is 5 divided by 2 r square into v1. And what is the speed of v1? Now they're asking how many times has it increased. So I'll take it as v1, right? Equals a2 is 5 times. The final radius is 1.25. 1.25 is 2.5 divided by 2 or 5 divided by 4. It's 5 divided by 4 and it's square into v2. So I have to find how much is v2 in terms of v1 or how many times v1 is v2. So I have to isolate v2, so I'll get the value. So 5 to 5 basically cancels out. 5 square to 5 square cancels out. So 1 over 2 square is 4 into v1 equals 4 square is 16. So 1 over 16 v2. So I can cancel out this in here. 2 times 1, 2 times, sorry, 4 times 1, 4 times 4. So v2 equals, if I cross multiply the flow, 4, it's 4 times v1. So it has increased by 4 times, right? Has increased by 4 times. So the answer is by 4 times, right? Answer is by 4 times. Answer 2. Third question. Consider the following statement regarding fluid particles of a fluid flow that travels in a horizontal uniform tube that follows Bernoulli's theorem. Speed of the fluid particles traveling along a streamline is speed of the fluid particles traveling along a streamline is constant. Yeah. So this is basically correct. Speed of the liquid particles traveling along a streamline is constant. So if you take the fluid particles traveling along a streamline, their velocities at these points are equal, right? But from place to place the velocity may differ, but if it is in a certain place, in a certain point, the velocities are equal, of course, right? All these three velocities of these three particles are equal at these certain points, but in different places their velocities are different, but at a certain point their velocities at that streamline is equal. So the speed of fluid particles travel along a streamline is, that is true. The kinetic energy of fluid particles in a unit volume is, this should be half, not 12, half rho v square. I think it's a typo, so it's half rho v square. That is true. Kinetic energy of a fluid particle in a unit volume is half rho v square. That is true. The speed of particles close to the center axis and near the wall of the tube are different. So if it is something like this, like which have friction or which has let's say sort of like even the fluids have friction, you know, when it's moving the fluids have friction, and when it's moving through a tube there are attractive and repulsive forces with the walls of the canal that it is moving. So when it comes to the walls, closer to the walls, their velocities will be less, and when it goes to the middle the velocity will increase, and then again to the wall the velocity will change. So the velocities of these different points are different when there are friction in the canal or in the fluid stream. So in Bernoulli's theorem we consider the friction from the fluids are 0. So therefore this is not correct because they have to have same velocities, right? They have to have same velocities. So answer C is incorrect. Only A and B are correct. right? Only A and B are correct. So the answer 2, right? Answer 2. A steel block of mass 5 kilogram contains an air-filled void inside, right? Means like if this is the metal and its mass is 5 kilograms, there's a void. Void in the sense air-filled void, sort of a hollow part which consists of air, right? When it is completely immersed in water, 550 milliliter of water is displaced. So when you immerse this whole object in water, 550 milliliters of volume is displaced, right? What is the volume of void? They are asking. Density of steel is 8 gram per liter. Density of water is 1 gram per milliliter. So you have to put Archimedes, isn't it? So when you immerse the object, volume will be displaced, isn't it? And that volume is equal to the volume of the whole object, right? Uh, Now, if we applied the upthrust, right? If we apply the upthrust, that U equals 0 G, by that we can take the volume that was displaced, right? We can take the volume that was displaced, and the volume that was displaced is given, right? Right. So density of the steel is given. So we can, if we have the density of the steel and the actual mass of the steel, we can find the volume, the actual volume of the steel, isn't it? Because D equals M over V, right? So then density is 8 gram per milliliter. And the mass, let's take it as 5000 grams because this is in grams. I had to put this mass in grams as well. So 5 kilograms, 5000 grams divided by volume. So by this we can take the volume. How much is the volume? 5000 divided by 8. How much is 5000 divided by 8? 625, right? It's 6000, sorry, 625 milliliters. Now this is the actual volume of the object, right? Right. So now this is the volume displaced. That is the total volume of the object, right? This should be the actual volume of the object, like the metallic part. So if we deduct 6 to 5 from 550, which is hold on a minute, right? So this is the displaced volume, and this is the actual volume of the other steel. Is this correct though? Like the simplification, V divided by 8, density is 8 gram per milliliter. This is 5000, of course. 5000 divided by 8 is 6257. Yeah, that's okay. So yeah, then the difference of these two, like this is the displaced volume, this is the actual volume it's supposed to be. So the extra should be the volume of the void, isn't it? So it's 75 milliliters, right? It's 75 milliliters. Answer should be 4, right? Answer should be 4. Right. Right, come to the next question. Rectangular canal narrows from a width of 8 meters and depth of 2 meters to a width of 4 meters and depth of 3 meters. If water flows at 3 meters per second in a wider section, what is the speed of water in a narrow section? So it's again basically continuity equation, isn't it? It's basically the continuity equation. So if it is continuity equation, A1 V1 should equal to A2 V2, right? A1 V1 should equal to A2 V2. So it's something like this, right? This is narrowing down here to here, right? Sort of something like this, right? So the area here is 8 into 2, and area here, and the velocity is 3 ms minus 1, and area at the narrow part is 4 and 3, 4 into 3. They're asking the velocity here. I'll take this as v2. So the formula is a1 v1 equals a2 v2, which is the continuity equation. So here the cross sectional area is 8 into 2, and the velocity is 3. Here a2 4 into 3, velocity is v2. We have to find v2. So now 4 times 1, 4 times 2, 3 times 1, 3 times, cancels out. Now v2 equals 4, right? v2 equals 4. So it's 4 ms minus 1. 4 ms minus 1. Right. Sixth question. A container with water of total mass 5 kg is placed on a balance as shown. Okay, so there's supposed to be a diagram. A sphere of mass 1 kg is suspended by a light string and immersed in water. The tension in the string is 5 newtons. What is the reading of the balance? Right? What is the reading of the balance? So have to draw it. Something like this. Container with water of total mass 5 kg is placed on a balance as shown. Okay. So let's say 5 kg is there. Let's take it as like this is 5 kg, which means 50 newtons. Okay. Container with water of total mass 5 kg is placed on balance. No. This is not what they're telling. So it's a container with water and the balance shows 5 kilograms. That's what they're telling, right? Container with water, total mass of 5 kg is placed on balance as shown. So container plus water is 5 kilograms. A sphere of mass 1 kilogram is suspended by a light string and immersed in the water. So you've taken a light string and 1 kilogram of mass is immersed inside the water. The tension in the string is 5 newtons. So there's a tension in the string that is 5 newtons. Right? What is the reading of the balance? They're asking what is the reading of the balance now when you immerse 1 kilogram of mass. So think it in this way. So there's 5 kilogram of a mass there, and when you immersed it, there's 5 newtons of a force in the uh, Bohr scale, which means the weight of this mass is how much? The weight of this mass that is immersed is 10 newtons. This will be 10 newtons because 1 kilogram into 10 is 10 newtons, right? And the tension here is 5 newton because the tension should be the reading of the uh, Bohr scale, right? So now tension is 5 newtons, weight is 10 newton, which means of this weight, 5 newtons of a weight or 5 newtons of a force is carried by the Bohr scale or the tension of the string. So tension of the string is pulling up 5 newtons while the weight is pushing down 10 newtons, right? The tension of the string is pulling up 5 newtons while the weight of the mass is pushing down 10 newtons. So 5 newtons of a force is acted downwards out of this 10. Only 5 newtons is acting down out of this 10 newtons. And there's 5 kilogram of a weight of the container in water, that is 50 newtons downward. So 5 newtons downward, 50 newtons downward together is 55 newtons. Or in kilograms, that will be 5.5 kilograms because 55 newtons is mass into the acceleration of gravity. So if you divide the weight 55 by 10, it will give you the mass, right? So it's 5.5 grams. Right. So that's the total MCQs, right? And now shall we come to the electricity part, right? We'll come to the electricity part. That's electricity. Okay. This is electricity. Let's discuss this one. So the diagram shows a fixed coil connected to center zero galvanometer and a movable magnet. Consider the following situations. So as it says, it should be a diagram like this. So it's a fixed coil connected to center zero galvanometer, something like this. It's a fixed coil, something like this, right? Connected to a center zero galvanometer. Center zero galvanometer is something that can move both the sides. It can go here, it can go here. It can go counterclockwise and clockwise both, right? So this is the coil, right? Then they have a movable magnet and they're trying to move it towards and outwards. So this is the magnet, let's say. This is the north pole, this is the south pole, right? There's north pole and then there's south pole. Right. So look at the first statement. Moving the magnet rapidly towards the coil. Okay. Keeping the magnet stationary inside the coil. pulling out the magnet kept inside the coil rapidly. Pulling out the magnet kept inside coil rapidly. Okay. Under which situation can the galvanometer deflection be expected? So galvanometer will deflect or a current or an electromotive force will occur only if, right? Only if there's a change of reflux of the magnet, right? If there's a change of reflex of the magnet, then there will be a electromotive force or electric current. So the magnetic reflux has to change. So when you are moving it, if the magnetic reflux changes, then there's an electric current. So think about it. So when you move the magnet in, right? When you move the magnet in, the magnetic reflux will change, isn't it? Through the coil, the magnetic reflux will change. And if you take it out, right? If you take it out, if you take out the magnet, the same will happen, you know. The same will happen. Means again they will change the magnetic reflux, right? If you take it out, the magnetic reflux will change. Get it? The magnetic reflux will change. So when the magnetic reflux changes, a current or electromotive force occurs, which means the center zero galvanometer will start to move. So in both the instances, when you move it forward and move it backwards, there will be a deflection of the galvanometer. But if you kept it in the middle, right? If you kept it in the middle, the magnetic field will be there, or the magnetic flux will be there, but there won't be any of a magnetic flux change or magnetic field change. There should be a disturbance there. There should be a disturbance there. The magnetic field should be disturbed. So if you kept it in the middle, there will be no change of the magnetic field or the reflux. So there will be no electric current moving, right? So if you think about it in that sense, so the first one, moving magnet rapidly towards the coil, of course a current will occur. Keeping the magnet stationary inside the coil won't. Again, pulling out the magnet kept inside the coil rapidly, that will, right? That will, right? So first one correct, second one is not, third one correct. So under which situations the galvanometer deflection be expected? Only A and C. A and C. Right, A and C. Second, four identical bulbs P, Q, R and S, each rated as 1.5 volt, right? Each rated as 1.5 volts. 100 milliwatts are used to make the following circuit. Okay, so each bulb is 1.5 volts. I'll just label it here, 1.5 volts. So each and every one are likewise, and 100 milliwatts, right? Right. Consider the following statement regarding the circuit. The intensity of the bulb P is higher than the intensity of the bulb Q, right? Consider the following statements regarding the circuit. The intensity of the bulb P is higher than the intensity of the bulb Q. What do you say? Intensity of the bulb P is higher than intensity of the bulb P is higher than the intensity of bulb Q. So this is Q, this is P, right? So you have to check intensity of the bulbs. So how do you check the intensity of the bulb? How do you compare the intensities of the bulbs? This is how. It's basically the power, right? If more power is there in the bulb, or if the more power is consumed by the bulb, there's more light. More the bulb consumes the power, more the light. Now think of it in this way. Now if it is the power. Basically, it's about VI. So you basically have to think in the terms of VI. More the VI, more the power, more the intensity, right? More the VI, more the power, more the intensity. But don't, like, if there's no any other option, you can go into other equations like V square over R, I square into R sort of equations. But the best equation to compare two of the intensities of the bulbs are VI, because VI is the base formula and all the two other formulas are the derived formulas. So when it comes to the intensity of a bulb, remember, if you have the opportunity to compare VI, then do that, right? Rather than V square over R or I square R, right? So I'm going to do that now. So this is the number of volts the battery has. So these 3 volts will come to here, and this 3 volts has to divide through the bulbs. So for that, you need to have the resistances of the bulbs, right? You need to have the resistances of the bulbs. So this is, anyway, we'll take it as R. So they're supposed to have the same resistance, right? Because they are the same bulb, so they have to have the same resistance. So I'll take the resistance of the P as R. And think about the resistances of these 3, or the total resistance of these 3, because we have to divide the voltage between this and this, because these are 2 parts. This and now this is staying a parallel combination, this is linear. So we have to bring this to the linear combination, so we can divide the voltage into these 2, right? The voltage divides in linear combination as per their resistances. Now this is somewhat linear, but this is parallel, so we have to bring this down to linear, so we can divide the voltage between this and this part, right? So for that, I'll have to shrink this to one circuit. How do I do that? Because it's parallel combination, that's what we learn in the parallel combination. Now these 2 are linear, so R1, R plus R is 2R, and this is R. So if 2 of the resistances are parallel and different in values, what we do is we multiply the 2 of the resistances. This is R and this is 2R, and we divide it by the addition of the resistances. This is R and this is 2R, so R plus 2R. So if I simplify this, that will be 2R square divided by 3R, right? R plus 2R is 3R. So 1 of R to R cancels out. That will be how much? 2 over 3R. That will be 2 over 3R, right? That will be 2 over 3R. Now the resistance of this whole part is 3 over 2R. Sorry, 2 over 3R. The other way around. The whole part is 2 over 3R, which is less, isn't it? 2 over 3R is less actually. You understand that? 2 over 3 is less, right? 2 over 3R, right? And this is basically R. So this has a loss, this has a less resistance, this has more resistance, which means this gets to have more voltage. I hope you understand. The larger the resistance, more the velocity it contains. Okay? Larger the resistance, more the voltage it takes, right? So this is 2 over 3R, this is R. Therefore, more voltage is divided to the larger resistance. And if you don't remember, this is how you take it. You take the total resistance. I'm going to go into like simple details, because I know that in fluid mechanics and electricity are a bit confusing with the questions, and that's okay, right? So this is what basically it is. You take the total resistance and you take one of a resistance as a fraction of it. Total resistance and a fraction out of it, and you multiply it by the total velocity. So you get the fraction of voltage that should be there in one of a resistor, right? You take the total resistance, you take one of a resistance as a fraction of it, then you multiply it by the total voltage, so you get the fraction of voltage to one of that resistor. So what is the total resistance now? That is R plus 2 over 3R. So this is a mixed a mixed fraction. You have to convert this into a proper. So you cross multiply this and add to the other. 3R plus 2R, it's 5R divided by 3. So this is the total resistance here, right? This is the total resistance here. 3 into R is 3R plus 2R is 5R. Okay. So this is the total resistance here. And out of this, you have to divide. This is again 1.5 something. Here. Or the easy thing is you take it as a direct fraction, because this is, if you take it as a direct fraction, R is to 2R over 3, right? R is to 2R over 3. So if you cross multiply the both, that will be 3R is to 2R. This is the actual ratio, right? 3R is to 2R. So if you divide the voltage into this, as you see, this gets more and this gets less, 3N and 2R. So it is 5R both together, right? It is 5R both together, and 5 out of 3 is to this resistor, right? 5 out of 3 is to this resistor. Right? 5 out of 3 is to this resistor, and 5 out of 2 is to complete this resistor. So if you take, this is the fraction of resistance, and the voltage is 3. 3 into 3 is 9. 9 divided by 5 is 1.8 volts, right? So out of 3, 1.3 volts is shared to the P. So rest of the voltage is gone to this part. Sorry, 1.8. 1.8 is gone to the P. 1.2 of a voltage is gone to this part, right? This total part, parallel part, right? Now, so the current coming out will be a common value. Let's say I. So I is coming here, coming here. So the I is totally going through this, right? I is totally going through this, but the I divides into 2 in this part, right? I divides into 2 in this part. So if you compare these two parts, this is 2R and R. So again here, the current divides as per the fraction of two of the resistances here. One is R. Here these two together is 2R. So total resistance is 3R there in the parallel combination here. This part and this part, the whole together is 3R. Out of all the 3R resistances, 1R of a fraction of current is going one way. The other part is 2R out of all the 2R. Right? 2R out of all the 3R is moving in another way. So if the current is I, right, 1/3 of current is moved in one of a side, and if the current is I, 2/3 of current is moving in another side. So out of these two sides, higher the resistance, lower the current goes, right? Higher, now the I is coming to here, right? I is coming to here. Now it's going to divide, and this is how it divides. The total is 3R. Out of 3R, there's a R over 3R fraction, and there's a 2R over 3R fraction, right? So out of this fraction, 1/3 of the current is moving in one of a side, 2/3 of a current is moving another side. So more the resistance, lower the current, which means through R, the lowest current should be moving, which is 1/3 of the current. So 1/3 of I is moving here, right? There is a different color here. 1/3 of the current is moving here, right? And here it's 2/3 of a current is moving here, right? 1/3 of a current is moving here, 2/3 of a current is moving here. Get it? So now we can easily compare these things, right? So if we compare VI, more voltage is here and complete current is here. So if we compare P and Q, VI of this P is greater, 1.8, and I is complete, right? And if you compare this one, the voltage is even less than 1.8, and even the current is 1/3 of the current moving. So definitely the VI or the power of Q is less than P. So the intensity of P is of course greater than Q. So the first statement, the intensity of bulb P is higher than the intensity of bulb Q, is of course correct. Get it? It's totally correct. B, the intensity of the bulb R and S are the same. Compare R and S. So R and S both gets the same voltage because they have same voltage difference 1.2 and they are equal. So 1.2 will equally divide into R and S, right? 1.2 volt will equally divide into these two. So they have the same voltage and it moves the same current, right? Through the two of the resistors, the same current moves 2 over 3I, right? Or 2/3 of I. So same voltage, same current VI. So same VI. So the statement B is also correct, right? Statement B is also correct. Statement C, the intensity of the bulb Q is twice the intensity of bulb R. Intensity of bulb Q. So if we compare the intensity of bulb Q, that should be 1.2 V into 1/3 of I. That is the intensity of power of Q, right? VI, no? So intensity is power basically. And if we compare the intensity of R, intensity of bulb Q is twice the intensity of bulb R. Yeah. If we compare R, PR, power of R, right? Power of R is again VI. So what is V in R? That is 1.2. No, it's not 1.2. You can take it as 1.2 if you want, but like 1.2 divides into these two equally. I hope you understand that. Because the 1.2 is between two of these sides. When මේ sides දෙක පැත්තනේ. You can make parallel combination එකේ ඔක්කොටම. The 1.2 is for the everything in the parallel combination. And inside it, there are two of the bulbs. So that 1.2 should divide equal to these two parts. That will be 0.6 volt each, right? 0.6 volt each. So it's 0.6, right? It's 0.6 volts. And the current moving through it is 2I over 3. So if you compare this, right? If you multiply this by 2, get it? If you multiply this by 2, would you get this one? If you multiply this by 2, would you get this one? If you multiply this by 2, that will be 1.2 volt into 4 I over 3. So it's not equal to this one, right? I'm sorry. You don't have to do that. If you multiply this by this, that will become 1.2 Vi, right? Divide by 3. If you multiply directly by this, 0.16, sorry, 0.6 into 2 is 1.2. So Vi over 3. Again, this is the same, right? 1.2 Vi over 3. So yeah, if you multiply this, so if you multiply, now this is basically this. That's the thing, isn't it? Both of the powers are same. P and sorry. Did I compare this correctly? So the statement B, the intensity of the bulb R and S are the same. Yeah. So that is correct. Intensity of the bulb Q is twice the intensity of bulb R. No, they are same. Do you see that? 0.6 into 2, 1.2 Vi, 1.2 Vi over 3 is the same. So P and Q and R are same. Right? Q and R have the same intensity. Do you see that? 1 point, if you multiply this, that is 1.2 Vi over 3. Even this is 1.2 Vi over 3. So the last statement is wrong because they have the same intensity, isn't it? They have the same intensity. So the statement C seems to be wrong. So A and B only are correct, right? Only A and B are correct. I hope you understood it. Right? So take us few seconds and try to get the idea. So I explained it a little bit further for your basic understanding. You don't have to go this much, but it's better when you understand it this much. It'll be easier to get the answer, right? So take a moment, take the notes if you want. Right? If you have any of the questions, feel free to ask, even if it is in the live. Right. So come to the next one. Question 46 and 47 are based on ABCD circuit diagram below. Right. So there's a ABCD diagram below. As you see, what is the voltage difference between A and B? Right. What is the voltage difference between A and B? So let's find out. Right. Right. So we have to find the voltage difference between A and B. Right. A and B. Okay. Okay. So now we have to find the voltage difference between A and B. There are two of the batteries and they're in the parallel combination. Right? Two of the batteries are there in the parallel combination. So when they're in the parallel combination, the total voltage affected to the whole circuit is same. Right? It's like capacitors. If two of the capacitors are parallelly connected, the total voltage will be the same, right? The total voltage that it can give will be the same, right? So 1.5 volt coming out of this, and because of this R, let's say, sort of a voltage is dropped, right? So because this one is dropping a sort of voltage, the total voltage that will be supplied to the circuit will be less than 1.5. Even same happens in this battery, isn't it? There's 1.5, and because of this resistor linearly connected to it, sort of a voltage will be dropped, be equal to like this one. So this is like an internal resistance of this battery, and this is like internal resistance to this battery. So they are basically two of the batteries with the same voltages connected parallelly, isn't it? These two are like two of the batteries connected parallelly. And if the batteries are connected parallelly, no matter how many number of voltage batteries are connected parallelly, if it is the same value, the total voltage that is supplied to the circuit will be the voltage of 1. If it is the same voltage, parallel combination added, then voltage is only 1.5. And let's say if this was 1.8 and this was 1.5, so the voltage of the circuit will be of the greater voltage, which is 1.8, right? 1.5 will give no effect because it has a greater voltage than this one. So if it is parallel combination, remember the voltage will be same for the circuit. They both will provide the same voltage, so with the same voltage running through the circuit. And if one is greater, the greater one will be supplying the voltage to the whole circuit, right? So this is basically two of the batteries connected parallelly. So we can assume we have only one battery, right? We have only one battery. So if we have only one battery, we can string these two uh, lines to one by taking the equivalent resistance of the circuit. So let's say it's only a one battery of 1.5 volt. So these two R's, right? These two R's will become parallel combination now, right? These two will become parallel combination now. So that will be how much? That will be R over 2, because same resistance is combined twice. So one resistance of 1 divided by 2. So it will be R over 2 here, right? It will be R over 2 here. And another 2R is there. Another 2R is there, right? Another 2R is there. And the voltage is 1.5 volts. So what's the question again? Voltage difference between A and B. This is A, this is B. So now voltage 1.5 is divided equally between, not equally, is divided between two of these resistors depending on their resistances, right? So the ratio is R over 2 is to 2R, which is basically R is to 4R. So it's 5R over 4R. So 4R is basically this one. This has the higher resistance compared to this one, right? 5R over 4R is there in 2R. Sorry, yeah, in 2R. So you multiply this by the total voltage, which is 1.5 volts. So you get the fraction of voltage to this resistor, right? So R to R cancels out. This is, you got it correct, right? R over 2, because these two are parallel, R over 2. So R over 2 and 2R, R over 2 and 2R in linear combination. So the voltage is supposed to be divided between these two as per their resistances. So the ratio is R is to 4R when you cross multiply it. Yeah, so yeah, all good. So altogether it's 5R. Out of 5R, the resistance of 2R is 4R. 5R, 4R. Out of that, 1.5 volt will be divided between. So how much of a fraction will go to 2R? So R to R cancels out. 5 times 1, 5.5 times 0 0.3. 0.3 times 4 is 1.2 volts. Is there any answer like that? Yeah. Third answer, right? So third answer is 1.2, right? Third answer is 1.2. Yeah. So what is the voltage difference between A and B? Is actually 1.2 volts, right? It's 1.2 volts. Yes. Understood it? Right, come to the next one. What is the power dissipation ratio between the resistor 2R and the resistor R between C and D? What is the power dissipation ratio between the resistor 2R and R? Resistor 2R. So what's happening there? I think the diagram should come to the last question. So what is the power dissipation between the resistor 2R? It's 2R, okay. And the resistor between C and D. So I have to compare this and the other one. Power dissipation of this one and this one, right? Power dissipation of those two. So as I said, power dissipation is basically VI. So if you know VI, then you can apply VI easily, right? So now, the voltage that comes to 2R is 1.2 volts, right? So this is 1.2 volts. We found it out, right? So rest of the voltage that is there should go to R here and R here and their parallel combination. Get it? The rest of the resistance should go to this and this, and they're in parallel combination. Therefore, they have to have the same voltage, right? So if this is 1.2 volts, the voltage of these two should be, the total voltage is 1.5, so this should be 0.3 volts. Get it? The voltage between these two should be 0.3, right? 0.3, right? So which means like it comes like in this way, right? So this is 1.5, and when it moves through here 1.2, the voltage here becomes no, this consumes 1.2. So yeah, this becomes 1.2 here. The voltage between these two becomes 0.3, because if this consumes 1.2, the rest of the voltage that is left should go to the other two resistors, and they are in parallel combination, so it should be 0.3, right? These two should have 0.3 volts of a voltage difference, and they're asking power dissipation is basically VI, right? So let's say if I of a current, now we have to find out the current coming out, right? We have to find out the current coming out. So how do you take the current coming out? It's basically V equals IR. So you have to take it from this circuit, because this gives you the total resistance, right? I'm going to use green. So if I put V equals IR, we can find out how much of a current coming out. So voltage is 1.5 equals I into R is 2R plus R over 2. That is basically 2.5 R, right? R over 2 is 0.5 R. This is 2 R. All these two together is 2.5 R, which is 5 over 2 R. So if we divided this, 5 times 1, 5 times 0.3, cross multiplied it, it's 0.6. I equals 0.6 divided by R. Even you have to divide it by R, right? This will be the current coming out of the battery. This much of a current will be coming out of the battery, right? So if you compare the VI, right? If you compare the VI, V of this is 0.3 and I is 0. Now we have to divide this I into two of the fractions now. So it's just like this is the total current coming out, but that current will be divided, right? That current will be divided. Now let's say this is the current coming out. So this current coming out will be divided into 2. So there's hold on, total current. I'll come to this one after we find the total current. So the current coming out of the battery is 0.6 divided by R. It comes here and is dividing into 2, right? So when it's dividing into 2, you have to consider the resistances of these two, right? It's 0.6 divided by R of a current coming out, and that current will be dividing into the ratio of these two, 2R and R. So it's 2R and R is 3R. So out of this total current, 3R. Now the ratio of these currents are, or the ratio of these resistors are 2R and R. So the total is 3R we can take. So 2 out of 3 and 1 out of 3 will be flowing in 2 of the resistors. So 2 out of 3R will be running through the larger, 2 out of 3 will be running out of the smaller resistance. That will be 0.4, right? If you multiply this, 0.4 divided by R square of a current will be moving through this, right? It's 0.4 divided by R square. And if we compare the other one, that will be how much? That will be, I'll write it here, 0.6 divided by R multiplied by 1 over 3R. That will be just 0.2 R square. So here it will be 0.2 divided by R square, right? So if we put VI now, right? So basically this has 1.2 of a volt and the current is 0.2 over R square, and the total value is this is minus 1, 24 minus 2. That will be 0.24 divided by R square of a power. This is VI. I applied VI. Yeah? If I applied VI to this one, right? That will be, the voltage is 0.3. This is V, and the I is actually 0.4 divided by R square. That will be how much? 3 into 4 is 12 R square. Minus 1, minus 1. That will be 0.12 R square. So power of this is 0.24 over r square. Power of this is 0.12 r square. So the power of this is twice this one. So of course the power of what was the question again? What is the power dissipation ratio between the 2R and resistor R? So it's 1 is to 2, isn't it? R and 2R. It's 1 is to 2, right? So R and 2R resistor. Ratio between the resistor 2R and R. So this is 2, this is 1. So it's 2 is to 1 because this times 2 is this. So it's 2 is to 1. So answer is actually 2, right? So take a note. There are simple ways of doing it. I went into the details so you understand it. You can take V square of R if you want, because you know that 2R is 1.2 and the resistance there is 2R. So 1.2 square divided by 2R, and the resistance of CD resistor is R, and the voltage is 0.3. So 0.3 divided by R square, V square over R, will give you the same ratio. Right. So I went into the details of VI because that will make it more sense. So once you understand it, you can go into the other answers like V square over R. V square over R is the easiest one, right? V square over R is the easiest one if you compare the two of the powers of these two, because R and voltage are the things we know, right? But I went into the terms of VI because VI is the exact thing that you give that gives you the correct answer, right? Hope you understood it. Right. So come to the third question. What is the voltage difference between A and B? We went through it. Okay. Fifth question. Water in a household electric kettle reaches 100 degrees of Celsius in 3 minutes, and the kettle is kept switched on for another 2 minutes. Temperature of water rises above 100. Now this is not electricity. That's heat. 6. At the critical temperature of material, its conductivity becomes 0. So critical temperature is there for the superconductors. If any conductor becomes superconductor, that happens in a certain resistance and a that happens in a certain temperature, right? This is what superconductors is. So if you compare the resistance and temperature, right? If you compare the if you compare the temperature and the resistance, if you compare temperature and resistance, in a superconductor, this is what happens. When you are reducing the temperature, the resistance of the conductor will be reducing. Remember that. When you reduce the temperature, resistance of the conductor will be reducing likewise. And all of a sudden, at a certain temperature, it will become 0, right? All of a sudden, at a certain temperature, your resistance will become 0. And this is resistance becoming 0, not the temperature. Resistance becomes 0 here, 0 R, right? When you reduce the temperature, the resistance will reduce, and at a certain temperature, the resistance will become 0. And the temperature here, that temperature here is called what? Critical temperature is called critical temperature. And at the critical temperature, the conductor becomes a superconductor because it's zero resistance, right? That's the theory, right? So the questions: at the critical temperature of a material, its conductivity becomes 0. That is, at the critical temperature of a material, the not the conductivity, the resistance becomes 0. There is room, right? It has its highest resistance. No, it becomes a superconductor. True. It becomes an electrical insulator. No, it becomes a semiconductor. No. So yeah, answer is 3. At the critical temperature, the conductor becomes super, right? Okay, 7th. An electrical appliance of power 6 watts is connected to the secondary coil of a step down transformer. Okay, so step down transformer. In step down transformers, in the primary coil or the primary circuit, the number of turns are more. In the secondary one, number of turns are less, right? And as per the question, it says an electric appliance of power 6 watt is connected to the secondary coil. So electric appliance of 6 watts is connected to the secondary, right? This is a step down transformer as well. So it's 240 volts converted into 12 volts, step down. Assuming the transformer is ideal in the sense there's no any power lost, or the power is conserved. The power in this one is the power in the other circuit as well. The power is conserved. What is the current in the primary coil? So it's basically the power is equal, right? V1 I1 equals V2 I2, which means the power of this one is 6, right? So it's basically V1 I1 equals V2 I2. So V1 I1 is the voltage, the power of the primary one. So voltage here is 240. You have to find the current I1. Voltage in the secondary is actually, you can just directly go into, VI, that is because 6 watts. As the machine is 6 watts, which means it consumes 6 watts of a power, that's 6 watts. So simplifying this, you can get the current of the primary, right? So 6 times 1, 6 times 4, I1 equals 1 over 40. That'll be how much? 0.025 amperes of a current. It's a small current. So it's in milliamperes, you have to, 1 multiplied by 1000 to convert this into milliamperes. 1, 2, 3. 1, 2, 3. 25 milliamperes. That's 25 milliamperes. Answer 2. Right? Answer is 2. 25 milliamperes. This is amperes. So 25 milliamperes. 0.025 amperes is 25 milliamperes. Right. So we can continue discussing the electricity questions if you want. What do you say? Or we can go into the heat. 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 Okay. Um, okay. Sure. Heat taking MCQs நால பூரா நான் பத்தி பாருங்க. Past papers. Uh, මේකේ ෆ්ලුයිඩ් එකේ ඔන්න අපි ස්ට්‍රක්චර්ඩ් එසේස් ටික කතා කරන්න ගමු. ඊට පස්සේ එහෙමම ඕනනම් එසේස් ටික කතා කරන්න ගමු. හරි. අපි දැන් එහෙම පොඩි බ්‍රේක් එකක් අරගෙන එහෙමම ඒතර ටික ඩිස්කස් කරන්න ගමු. හරි. මම ඉලෙක්ට්‍රිසිටි ෆ්ලුයිඩ්ම කන්ටිනියු කරන්න පුළුවන්. හැබැයි ගොඩක් නෑ. ස්ට්‍රක්චර්ඩ් එසේ තියෙනවා ඉලෙක්ට්‍රිසිටි වල 24 වල 23 24 25 පොඩ්ඩක් තියෙනවා. එකක් තියෙනවද? එක ස්ට්‍රක්චර්ඩ් එසේ එකක්. ඒකෙත් කැලලක් තියෙනවා. ඔක්කොම නෙමෙයි. ඉලෙක්ට්‍රිසිටි දෙන්න එසේ එකක් තියෙනවා. ෆ්ලුයිඩුත් එසේ තියෙනවා. හරිද? ඕකේ. ඉලෙක්ට්‍රිසිටි තමයි ඊළඟට තියෙන්නේ. ඊට එක MCQs 1 2 දෙකයි තියෙන්නේ. ඒ කියන්නේ 23 24 25. ඕකේ. හරි. අපි යන 30 minutes වගේ බ්‍රේක් එකක් අරගෙන 12:30 වගේ පටන් ගමු. ඊට ටික ඩිස්කස් කරමු. රයිට්. බ්‍රේක් එකක්. අද ඔළුව රිදෙනවා 12:30 වගේ. අම්මේ සැප.